In this video, we quickly learn how to use the built-in linear regression function in the TI-84 to compute the equation of the regression line and find the correlation coefficient for a small set of ordered pair data. So we're told that the data set we're looking at is the number of hours studied paired with the midterm exam scores for 12 students. So the hours studied is the x variable or independent variable, and the exam scores are the y variable or dependent variable. So to get the equation of the regression line, we start by entering the data in our calculator. So to enter data in a TI-84, we press Stat and then Edit. And I actually entered the data in advance just to save a little bit of time here. But I want to remind you, if you need to get rid of some old data in one of these lists, you can just highlight the list header and press Clear and then Enter. So once the data is entered, we hit Stat and then Calc. And then notice there's two different linear regression functions in here. The first one says linear regression ax plus b, but we're using a textbook that formats linear regressions as a plus bx. So we'll just go ahead and match that form. And we hit enter. It uses list 1 and list 2 by default. Go down to calculate. And so it reminds us the form of the line we're looking at is a plus bx. And it tells us that a is 49.83 and so on, and b is 6.48 and so on. So we sub the a and the b into the formula for our line, and it turns out the linear regression is 49.83 plus 6.48x. And I want to point out here, the interpretation of the slope is that for every increase of 1 hour in studying, we're predicting an increase of 6.48 points on the midterm exam. Now, by default, the TI-84 doesn't give a correlation coefficient out of the LinReg function. So to get that to appear, we go to Mode, and we arrow down to StatDiagnostics, select on and hit enter. And then we just go back and re-execute the LinReg function. So we hit stat, calc, and then we're going to go down to LinReg a plus bx, calculate that. And now a value of r and r squared are going to pop out. So we were asked for the correlation coefficient here, and that's r. And we'll just round that to 0.997. So remember, a correlation of 1 would be a perfect positive correlation. This is very, very strong. In the next video, we learn how to use the built-in hypothesis testing function for the significance of a correlation. I'll post a link to that video at the upper left, and I'll see you there.